Hello, my name is Dmitro, and this is demo project to test capability of Kafka message bus and Kotlin language for microservice development. When I was building this project, I had couple goals to test. Um, Particularly, I'm quite sure that Kotlin is already perfect language to be used with JVM-based languages and frameworks. And since I'm most familiar with Spring Boot framework, I wanted to test and to see how Kotlin is good to be used with that. So another thing to see is integration of Kotlin and Kafka. Particularly Spring Boot have a Kafka module, and the goal was to test to see how Kotlin will work with that. So as usual, I deployed this into Kubernetes into microservice way. So since in my past I already deployed a lot of Spring Boot framework, Spring Boot based services in Kubernetes. Um, so here I wanted to see how the Kafka and Kubernetes will work together. Also, Kafka provides scalable capability to run message over set of partitions related to the topic. And here, this is another thing that I wanted to test. On the other side, for partitioning, the application framework also have to provide capability for that. And particularly in this deployment, I wanted to test how the Spring Boot will make sure that every instance, like for every partition, here will be a unique consumers, and there will be like no overlaps where partition will be consumed by multiple consumers. And the last feature, not least, Kafka stores all the historical data, so all the messages that came through the Kafka and successfully processed is stored on the Kafka, and it can be replayed later in any case of any needs. This demo setup had some considered limitations. So the reason for that, I didn't want to spend too much time on this demo setup and like spend just a few days on this. However, I can consider that for production, Kafka have another capability that needs to be configured, like it offers high availability setup where the message stream, like where the partition of the topic is duplicated and replicated over a couple Kafka broker instances, and if one of the broker instances will fail, then another will take care and all the messages still will be delivered. Of course, it needs to be deployed with some health monitoring, so if the broker instance will go down, the automatic system will recover this automatically. Basically, another thing that is not that considered as limitation this setup is that I still use very straightforward deployment to Kubernetes. I'm not using persistent set. So if I will restart the Kafka pod, then all the persistent data will be wiped out. So for keeping the historical data, it should be deployed in a different way. However, I would say that on this deployment, just to deploy Kafka and Kubernetes, I think it take me like 2 or 3 hours. So quite short, quite fast, and it's good. So deployment. So my deployment consists of 3 main components. So in the middle is the Kafka. It's already said. It used to integrate the parts. So on the left side, here is the producer, which sends messages to the Kafka. So this producer is initiated by the REST API calls that can be invoked by the user or applications and wants to send a message to the Kafka. On the right side, the output is a Kafka consumer. It reads messages from the Kafka and sends these messages, like once the message arrived, it prints them to the stdout, so it can be used with log aggregator further. So particularly in this deployment, I wanted to test the Spring Boot, how can it manage instances. So here I'm running 2 instances of this of consumer service, and Spring Boot will automatically manage for me that consumer, that partition will belong only to one consumer. So for example, if I would run one instance of consumer, then all the partitions will be processed on the single one, like on one consumer. But if I will run 2 or more, then Spring Boot will guarantee that that partition is distributed like with the same load, like for 2 partition, 2 instances, it will be like 1 by 1 to 1, and it will not and it will also guarantee that the partition will not be consumed by multiple consumers, because it can lead to the situation where the message will be double processed, and we don't want it. So this is good. So the way the Spring Boot works is good. The project structure. The project structure it's split into 3 folders. It has an application. This is where the source code of the application is stored. Also I have documents. This is the place where I'm putting all the supporting document. So now let's have only this diagram there, and supporting scripts that helps me to install Kafka into Kubernetes, get some configuration for Kubernetes, general common configuration, and deploy my application to Kubernetes. So to build and deploy, basically here on this project, here's a shell script that I provided for convenience of use. So particularly have a couple dependencies. So this setup requires the OpenJDK installed of version 14. It also requires the Kubernetes. Particularly I've used micro Kubernetes with CureDNS enabled, and it's also required Docker. So the first step is to install OpenJDK. Needs to make sure that Java Home is configured properly. Then needs to install Kubernetes like micro Kubernetes, enable core DNS add-on, install Docker, and make sure that shall have all the necessary access to the kube control, to the Docker, to the micro Kubernetes command. So for convenience access, I've integrated the Kubernetes DNS with my desktop Kubernetes. So for this reason, I've updated my resolve conf configuration. So here in the project shell scripts that will highlight which configuration is to be placed there. So it looks like this. And then when I want to edit, I just need to update my resolve config. So particularly if we will compare this, it will look like this. So just make sure that, yeah, so this name server is here and search DNS is here. Just make sure that name server in the topmost line in the config. So this is like, this IP address is like is core DNS yeah, so this IP address is kube DNS instance that I just placed to my resolve conf. And after that, I can use like the names of my services deployed to Kubernetes just from my browser. So the next thing is to deploy Kafka. For this reason, I already provided scripts here. For that, so basically it just simply makes it's deploy couple Kubernetes manifesto files to there. So Kafka requires Zookeeper and Kafka requires itself. So the manifesto files for Zookeeper looks like this. So I'm installing the Zookeeper image and I'm exporting this as a service. So I can use this with DNS name Zoo1. And the Kafka it also looks like this. So here I'm deploying Kafka Docker image. It's bound to the Zookeeper and exposed with this DNS name for further use in my applications. So I can run this command. I can run this command. So here I want to install Kafka, and here's my install instruction. Basically, since Kafka already deployed on my Kubernetes, nothing changed. The next instruction is to install and deploy application. Basically, the scripts is here. It deploy first my demokafka producer, then it will install demokafka consumer. Also, it puts couple arguments for that, like port, number of replicas, and for particular service, here's like series of tasks to run. First, it will be built. Build means that it will be it will be compiled from the Kotlin source codes into the jar file. Then this jar file will be dockerized, it will be wrapped into Docker image. Then particularly micro Kubernetes that I'm using requires some workaround to make sure to push that Docker images into Kubernetes, and then the application and this Docker image will be deployed into Kubernetes. Then I'm just restarting to make sure that latest Docker image is applied. So let's see these scripts. So the build just run Gradle. Then it's been Dockerized. So the result of the Gradle run will be jar file, which will be put into Docker image. So here, how it looks like. So here's my Docker file. I'm using JDK. Here's my jar file. Copying this to Docker image, and this is my entry point to this jar file. So yeah, and this is my web jar. Then workaround for the micro Kubernetes. So I'm just exporting this image into archive file and pushing this archive to the micro Kubernetes to make sure that all the images in this archive will be available for Kubernetes deployment. Next thing is deployment. So for deployment, I'm generating a Kubernetes manifesto from the template. So template looks like this, just a parse script with placeholders to expand values from the environment variables. And like the manifesto based on the template for the consumer will look like this. It will have a deployment with demokafka consumer deployment, number of replicas, and service that bounds to this deployment. So particularly later, the application can be accessed using this DNS name. And the last instruction, not least, just in case I'm making the restart, it just simple scale to 0 and scale to configured number of replicas, and now the application is available for the further use. So basically here for usage I will invoke my producer that will send a message to the Kafka topic, and then consumer will read this message and write to the log. So let's start seeing what's happening in our logs. So here on the manifesto, you can see that consumers, all the pods in the consumer have this label. So now I can read logs of all the pods that have this label. And let's see what will happen. Things. Here's my log. Then I can open demokafka producer and send some messages to here. My super message. and execute. So we can see that this message is retrieved by the listener from different partitions. And here's like a command that was used, like I'm making a post request to this URL with this body content. That's it. Another REST API that I have here is on the consumer, where I can replay all the messages that are already there on the Kafka. So like I'm making this REST call to the consumer now, and it will read all the messages. So particularly this request was to the instance with partition 1, and all the partition 1 was read again. Basically I can repeat this separation as many times as I want, like demo message will play. And I will see it again and again. So this is how application is used. And the last thing is about the source codes. So as I already said before, the source codes are placed in the applications. So here I have like two applications, like consumer and producer. This application is simply thing generated from Spring Starter. So here I can choose Kotlin, like I prefer to use Java 14. Also I really like to use Gradle on my projects. And since I have REST APIs, I will need Spring Web Model, I will need Actuator, for Kafka I will need to have Kafka. Also you could notice that I've used Swagger. So Swagger, this is something that I add manually to here. Like I add couple of these dependencies for Swagger and this configuration. It's usual Spring Boot application. It starts with application file where like the entry point to start running the app. Then this is my producer. It has a controller like entry point for this API request. So this URL binning that we can see here. Then when I click in this button, the call is just going to here. Then all the logic from the controller I've decoupled to the service layer where I'm currently using Spring Boot Kafka template to send message to the Kafka message broker. And here, what else I have? I also have configuration for the Kafka topic. I'm using this Spring Boot capability to declare to create new topic on the Kafka broker with like specified number of partition I want. So all the things are configured through the Spring Cloud config. So I've used this nice Spring Boot annotation for that, like demokafka topic. And my configuration. So for production, I would prefer to use Spring Cloud Server, but here, for just to keep it simple, I just place this configuration to here with some DNS names that we can see in our manifesto files, like Kafka service port 9902. Same thing here, Kafka service 992. So this is a producer. This is a producer. So consumer is quite similar to that. So it's same template, same build Gradle scripts, same Swagger here. It also have very symmetric set of configuration. Just add couple few for Kafka as a consumer for Kafka. So the listener on the consumer looks like this. I'm using the Kafka annotation to read this topic name configured on property file, and then I'm just simply printing this to the log. So basically here's like some additional information we can see. So I'm generated some instance hash code just to distinguish in the log which service got a message, to make sure that to make sure that the partition is assigned to only one instance, like this. So here like that every partition have a correspondence. It's correspondent, so every partition correspondent to the instance. And here I'm printing this information and the message body, of course. Also for the replay functionality here, I'm using the Spring Boot Kafka API for SIG, where I can say like that this topic should be read from the beginning again and again, and this thing is also available through the REST API. So I can invoke that method through the REST API here. So this is the application. So thank you for your time, and thank you for watching this video.